Two masses connected by a massless string hang over a pulley that connected two inclines. Mass 1 is 8 kg and mass 2 is 12 kg. The coefficient of kinetic friction for both inclines is 0.21. Determine the acceleration of two masses. Given that M1 and M2 is 8 kg and 12 kg respectively, and mu k is 0.21, and we have the theta 1 and 2 is 26 degrees and 39 degrees, so we required the acceleration of two masses. The free body diagram of M1 shows that the horizontal net force equals tension minus kinetic friction of M1 and the x component of gravity of M1. The vertical net force is 0, so the magnitude of normal force of M1 is equal to the y component of gravity of M1. From the diagram, we can easily get that Fg1x equals M1 g sine theta 1, and Fg1y equals m1g cosine theta 1. Use the formula of mu Fn to calculate the kinetic friction of M1. For the M2, the horizontal net force is equal to the x component of gravity of M2 minus the tension and the kinetic friction of M2. The vertical net force is 0 as well, so the magnitude of normal force of M2 is equal to the y component of gravity of M2. Fg2x equals m2g sine theta 2 and Fg2y equals m2g cosine theta 2, and it times mu to solve the friction of M2. Treat M1 and M2 as an entire system, so the horizontal net force equals Fg2x minus kinetic force of M1 and M2 minus Fg1x, and use the formula of F equals ma to solve the acceleration. Put the value in the formula that we have to solve. The final acceleration of two masses is 0.28 meters per second square. The direction of the acceleration is clockwise.